Welcome back, grade 9 to period 2. We'll continue with the chapter number 1, number systems. So before we start the period 2, I would like to remind you yesterday's reminder, that is, be ready with a book and your pen. Are you ready? Great. Let's move on to your second lesson, irrational numbers. A quick review of what you studied yesterday. It was about, very good, rational numbers. And you know what are rational numbers? It is a number which is represented by the letter Q, which is in the form of a numerator and a denominator. It can be positive or negative number, but the denominator cannot be equal to 0. That's what we studied yesterday. Now, today we will move to the new part, which is irrational numbers. So it's the opposite of rational numbers. So we cannot write a number which is in the form of p by q. This is called an irrational number. A number which cannot be written in the form of p by q, where p is the numerator, q is the denominator, and they are integers. Let's see in details what they are. Now, irrational numbers cannot be written as numerator and denominator with natural numbers or integers, but it can be written either in the form of some symbols like pi, or in the higher classes you will study about the letter e, or square root of 2, square root of 3, and more numbers. Or the other way is to write it in the form of decimal numbers. Yani we will come to it in a minute. So irrational numbers, keep in your mind, cannot be written in the form of p by q, where p and q are integers. So instead, what are some examples of irrational numbers? It can be pi, square root 2, square root 3, square root 4 is not written. Have you noticed? It is not just by chance. It is not an irrational number, because square root of 4 is 2, which is a great rational number, because square root of 4 means 2. 2 can be written in the form of 2 by 1. So it is a rational number. So 5, square root of 6, square root of 7, square root of 8. Again, square root of 9 is not written, because square root of 9 is 3, which is rational number. And we can continue. So that's a small activity for you. You have to write numbers from 1 to 100. I'll just show you an example and please continue. Okay. So here we write from numbers from 1 to 100. For example, square root of 1, square root of 2, square root of 3, square root of 4 you can't write, because this is equal to 2. Is equal to 2. So we can write it. Again, square root of 5, square root of 6, root 7, root 8, root 9 we can't write, because this is 3. Again, square root of 10. And keep continuing until, I want you to write until 100, square root of 100, and see how many numbers from 1 to 100 are rational and how many are irrational. That will give you more idea. Okay. Now, so as I told you, it can be written in two methods, either by a decimal, which is written here as a decimal form, or it can be a symbol pi. And you have come across pi in smaller classes for finding the area of a circle or circumference of a circle, and you replaced either by 3.14 or 22 by 7. But now you understand that these both numbers are not 100% accurate. For easiness in calculation, we use 3.1 or 3.14, 3.14 or 22 by 7, but there is an error of 0.0000 minute 1, something. A minute error is there, but it is ignored. That will be ignored. Again, square root of 2, we can write it as 1.414, and we will learn how to find this one using a number line in a minute. This is another example of irrational number. Now, let us go through a few details about the historical part of irrational numbers. It was Pythagoras. You can see the picture here of Pythagoras. Pythagoras is the first mathematician from Greek, Greece, who discovered that there are numbers other than rational numbers in the world. And a quick review of all the set of numbers that you studied. First, you studied the inner circle, which is natural numbers. In addition to that, there are whole numbers, which has just a 0 extra. Then you have Z, which has negative numbers. Then rational numbers, which has fractions, negative, positive, all the numbers. And now you studied about irrational numbers, which is represented by the letter I, the first letter of irrational number. Now comes to the new idea or new term, which is called real numbers, that is represented by the letter R. So real numbers has two parts. What are they? We have real numbers can be represented in the form of Q, rational number, or it can be an irrational number, which is represented by the letter I. So these are the symbols. These are the terms that you studied before, and some examples are also given to you here. Let's move on. This is another activity that you can do it yourself. So just pause here and try to make this yourself in your copybook to make it clear. You see here, have you noticed? Under the letter R, you have Q and I. And I, there is only one category, irrational number. But under the category of rational numbers, you have integers, whole numbers, and natural numbers. But irrational numbers, it can be written in two forms, either using a symbol by like root 2 or pi, or it can be represented by decimal, how, which will not end, or it will not repeat. These are the decimal expansion. That is your chapter 3, sorry, lesson 3. And these are some examples. Now, so again, once again, what are real numbers? It can be categorized into, can you say? Yes, rational numbers as one group and irrational numbers on the other group. But notice that none of the rational numbers are irrational numbers and none of the irrational numbers are rational numbers. Is that clear? Great. Now we have to find the value of square root of 2. Can you guess what's the value of root 2? To find the value of root 2, we need to recall what you studied in grade 8, the Pythagoras theorem. You remember Pythagoras theorem? Pythagoras theorem is working in a right triangle where you have 90 degree. You have a 90 degree here, and the side opposite to 90 degree is called, can you say what's the name of the opposite side? Anybody? Yes, good. It is called hypotenuse. We have to apply the rule. Square of the hypotenuse is equal to square of side 1 plus the square of the second side. This you have studied before, just to recall. Okay, so our question is to find the square root of 2. This is done using a number line, and we apply the Pythagoras theorem there. Let's see how is it. C square, we need the hypotenuse. We consider square of C as the hypotenuse. C is considered as the hypotenuse, and side, one of the side is 1 and the other side is also 1. Why they are 1 and 1, you will understand with the next example. And you know, 1 square is 1 and 1 plus 1 is 2. So what do we have now? C square is equal to 2. C square is equal to 2, and we can say that when you take square root on both the sides, take root here and root here, so you get the answer that C is equal to square root of 2. So let's use a number line. I chose number line from -3 until 3, and we are using a triangle there. See, have you noticed one of the side is 1, another side is also 1, and the hypotenuse is C. C is the hypotenuse. This is 1 unit, and this is the height is also 1 unit. So 1 square plus 1 square, 1 square plus 1 square is 2, which will give you C, which is equal to square root of 2. So the length from 0 until the top of the triangle, this is the measurement of C or square root of 2. This is, let us consider this as a radius. So when you draw a circle using this radius, see what will happen. It will come and meet at a point on the line which is very close to 1.5. And when you expand this number line, you can see that this is between 1.41 and 1.42. So in general, we say that the answer of C, which is C means, you know, C is square root of 2. So C, which is replaced by square root 2, is equal to 1.4. This is just an example of square root 2, and in this way you can find the square root of any value. Let's see an example of square root of 3. So again, we need the base should be equal to 1 unit. And the height can't be 1 unit because if it is 1 again, it will be square root 2. We need square root 3. So there should be a change. So it will be 2. Why is it 2? I will explain it here in detail. Let us see. Here it is. We need to know the answer of 3, square root of 3. So we know that 3 can be written as 1 plus 2. Why I'm writing 1 here? Because we need the base as 1 and the height keep changing. So this is very clear. 3 is equal to 1 plus 2. Now, what's 1 power to 1 square? 1 square is 1 again. Also, we need the square for the other side to form the hypotenuse. To know the hypotenuse, we need the square of the other side. So I'm squaring here also. 1 square is 1, there is no change, right? But 2 square is 4, there is a change. To remove the effect, we take the square root. Now what is the effect? This power 2 and square root will get cancelled. So it is again 1 plus 2, which is 3. And the last step is we square on both the sides. We take the square root on both the sides. So it will be 1 plus square root of 2. This is how you are getting the value here. You see, this is how you get it. Can you match these two? Great. Okay, now in general, how can we find the value of any letter n to find the value of its root? For example, let us take the square root of 7. How can you write 7 in this general form? Look at this one. It's easy. When you look at this general form, you might get confused a little bit, but you see, first you write 7 is equal to, can you say how is it? Right. 7 is equal to 1 plus 6. Remember, 1 should be the first. Always write 1 here. And then what's the next step? Step 1, we write, that is step 1. Step 2, we write 7 is equal to 1 square plus 6 square. But you can see these two are not the same. How you make it same? Take square root. When you take the square root, the effect of the square root, this one and this will cancel, so it will be 6 again, right? And now the last step is, we have now this one. Now take square root on both the sides. You see? This is how it is written in the general form. Okay? Great. So now you can try with any number as you wish. First you start with 1 plus the number just before it. And then you will get the answer using a number line. Okay, now let me move on to the exercise. First question is, it's a true or false question. Is every irrational number, no, the statement is every irrational number is a real number. Is this a true statement? Yes, because you remember the trick that I gave you in grade 1? All the numbers which are in the first sets are in the second sets, or the sets in the lower part. Irrational numbers are coming at the top, and then comes real numbers. So irrational is at the top and real is down, so it is true. And also real numbers has two collections only, rational numbers and irrational numbers. So definitely irrational number is a part of real number. Great, next question. Every point on the number line is in the form of square root of m, root m, where m is a natural number. M is a natural number. You can start from 1, 2, 3, 4, any number you want. But don't forget, you can even use a negative sign here. So if you have a negative sign, you will get a negative number. So if you have positive numbers, you can represent it on a number line and find any value. So no problem. So square root of all positive natural numbers can be represented on a number line, but if you have a negative sign here, it can't be. And this is something that you haven't studied yet. You will study about it in grade 10 and the higher class. They are called complex numbers. Complex numbers include a number which is inside the root with a negative value. Is that clear? So any natural number with a root can be represented on a number line if it is positive. But if it is negative, it can be represented on a number line. Okay, let's move on to part 3 of question 1. Every real number is an irrational number. So it's the opposite. We are choosing a set of number which is down and we are saying it is there in the upper one. No, it is not true, because real numbers also has rational numbers in it, and rational numbers are never irrational. So this is a false statement. Just pause a moment, read it again, it will be clear for you. Now moving on to question 2. Are square root of positive integers irrational? All the positive numbers, okay, we studied that square root of m, if it is positive, it's irrational, but not always irrational. Look at this example. If you take square root of 9 is 3, it is a rational number. Root of 16 is 4, again rational number. So these numbers will not be irrational, but they are rational numbers. The idea here is we can say root of 9 equal to 3 or root of 16 is equal to 4. They are rational numbers, not irrational numbers. Hope it's clear. Our next question is to find the value of root 5. And I'm sure by now you are an expert to rewrite 5 in the form of, to write the sides in the form to make the sides of a right triangle. We need to have 1 on one side as base and 4, square root of 4 on the other side, because 4 is 5 minus 1. And let us try to represent this on a number line. Here I took a number line from -3 to 3, and let's insert a triangle with, as usual, the base is 1 and the height is square root of 4. Square root of 4 is 2, so the height will be 2. So the triangle is perfect now. We have the base is 1 and the height is 2. So the hypotenuse, let it be represented by the letter C, and this hypotenuse will represent square root of 5. Root of 5 is from 0 to the top of the triangle, which when we continue as a circle, we will get the value on the number line, which is between 2 and 2.5. Now, in this question, because the second side of this triangle is root 4, you can rewrite as 2. But did you ever wonder what if it is root 7? It's not easy to get a number, the value of root 7. So what you have to do is we have to connect from square root of 2, continue as a chain, square root of 2, then 3, then 4, then 5, 6, and 7. Only then we will get the number, or else we have to substitute the value of root 7 as the height of the triangle. Hope that's clear. Now here is a small homework for you. Just I'm sure you are an expert now. Take these numbers and write it in the short form that we learned. For example, can you try the example of 10 here? I will help you a little bit and then you can continue. So we can rewrite 10 as 10 is equal to, first should be, what should be the first number? 1. Great. Plus 1 plus what give you 10? 9. Second step is we take the square on both the sides. And then the next step is to take the root for the second number only, because it will remove the effect and then change it. So that is the the way, and then you can continue with the rest of the numbers. And the second question is to find the value on a number line. And you have to notice that the number here is, you even have 17 and 26. So you may have to use a more larger number line to represent it. So that's all for today. Hope the lesson is clear and you are interested to continue the next lesson coming soon with the next period. See you soon in period 3. Bye for now.